Okay, welcome to the lesson on units and unit conversions. This is review from Physics 11. The metric system of measurement was created by French scientists in 1975. An international committee set up the Système International de Units, or otherwise known as SI. This system was set up so that scientists around the world could communicate with each other and use consistent measurements, units for measurements. So time, length, and mass are called base units because all other units can be described using these three units. The SI unit for time is the second. So time is also measured in minutes and hours, but the SI unit is the second. So we will be using that unit more often than not in science class. The SI unit for length is the meter. So sometimes you see length measured in other units like inches or miles or feet, but those are not standard units. So the standard unit is the meter, which you will be using in this course. The SI unit for mass is the kilogram. All other units are called derived units and are combinations of base units. Examples: meter per second is a combination of meters, distance, and seconds, time. Prefixes are used to change SI units by powers of 10. Note, the kilogram is the only base unit with a prefix. So here is a list of SI units and some of their prefixes. So, like for example, here you have nano, which means the symbol is an N, and it means 10 to the power of -9. So the full name, if we put it in front of a unit, would an example could be nanometer. You could also have nanoseconds or nanograms. So nano goes in front of the base unit. And then we have what's called the conversion factor, the relationship between 1 nanometer, the prefix, and the meter, the base unit. So 1 nanometer equals 10 to the -9 meters. So this unit would be used for something really small, like for example, the width of an atom. And then you have some units that are really large, like giga, which is 10 to the power of 9, which might represent the distance between planets. And then you have units in between. So some of the ones that you are more familiar with is the millimeter, milli, centi, like centimeter, and kilo, and an example would be kilogram. So you've been using some of these already, so this is just working with what you've done before. If you've taken Physics 11 with me, you've probably used the other units as well. If you've taken Chem 11 or 12, you've probably used the other units as well. Conversion factors. A conversion factor is a fraction or a factor written so that the denominator and numerators are equivalent values with different units. So for example, inches are still used because in the United States, they still produce and manufacture things with units like inches and feet. These are imperial units used a long time ago, but we still use them like in construction, or sometimes if someone asks you your height, you would tell them in feet and inches. So we still have to know how to use them and how to convert from these types of units to SI units. So 1 inch is exactly 2.54 centimeters. The conversion factor is written as a fraction, and it's written with either inches in the numerator or denominator. So there's two ways to write it. Here you see inches in the numerator, and here you see inches in the denominator. So there's always two ways to write any conversion factor. Unit conversions. Let's suppose you want to convert a unit from inches into centimeters. So 4.8 inches equals blank centimeters. We have to multiply the original number, 4.8 inches, by the conversion factor that you can use, and the unit you want to cancel should be on the bottom. So we are multiplying by 2.54 centimeters per inch. So we want inches in the denominator because we want inches to cancel. So units multiply and divide just like numbers do. So since you have inches in the numerator here and you have inches in the denominator here, the units cancel out. And that's what we want because we want inches to cancel and we want to end up with just centimeters. So when you do these calculations, you're multiplying and dividing numbers, but you're also multiplying and dividing units. So we multiply 4.8 by 2.54 and we get 12. And then we multiply inches by centimeters over inches and we get centimeters. So the final answer is 12 centimeters, rounded. You must multiply and divide the units as well. So as we just mentioned, the units of inches cancels, and that's how we end up with centimeters. Inches cancels out because the unit is both in the numerator and denominator. This works for prefixes and base units as well. So let's suppose you want to convert from millimeters to meters. So both of these are units using the meter, but the only difference is you have a prefix here, millimeter, and you're converting to meters. So you would use the same method. So we start by writing the conversion factor. This is where you can use the chart, and you do get the chart for quizzes and tests. So there's several ways to write this, and all of these mean exactly the same thing. So 1 millimeter is equal to 10 to the negative 3 meters, which is directly from the chart. Or we can multiply the 10 to the negative 3 out, and we can expand it to a decimal. So 1 millimeter is equal to 0.001 meters. Or we can multiply both sides by 1,000, multiply the left side by 1,000. If we do the same thing to the left and right side, the equation stays equal. So if we multiply both sides by 1,000, we get 1 meter equals 1,000 millimeters. And this is probably the conversion factor that you are most familiar with and most comfortable using. But you do need to get comfortable using the other ones as well. Or we can write it as 1 meter equals 10 to the 3 millimeters. Like I said, these all mean exactly the same thing. And you can use either one, any one of them in your equation. So which one do we use? Which one do you think we're going to use here? We would use 10 to the negative 3 meters over millimeters because we want millimeters to cancel. So it needs to be in the denominator. And then we multiply out, cancel the units. So when you do these questions, you have to show your conversion factor and you have to physically cross out the units to show the unit cancellations in all of your questions. You will get marked on that. And then we get our final answer. And then we can convert it into proper scientific notation. So it's 1.234 times 10 to the negative 1 meters. Now try using 1 meter equals 1,000 millimeters or 1 meter equals 10 to the 3 millimeters. Try using one of those and we should find that we get the exact same answer. You can try using 1 meter equals 1,000 millimeters if you feel more comfortable with that. So we get the same answer. To deduce the factor required to accomplish a conversion, simply construct it so that the units will cancel appropriately. Ignoring numbers for the moment, let's look at the form of some conversion factors. So here, for example, if you want to convert meters to centimeters, then you would multiply meters by centimeters over meters to get centimeters. If you want to convert nanometers to centimeters, you would multiply nanometers by centimeters over nanometers to get centimeters. Once the form of the factor is determined, it only remains to insert numbers which make the numerator and denominator equal so that the logical value is unity. So then after that, we just put our values in. Once we have the proper units in the right location, then we put our numbers in and we multiply out by the conversion factor. Let's try a more involved conversion. Suppose you want to convert kilograms to milligrams. You may not know a direct one-step conversion. In fact, the better method is to do the conversion would be to go to the base unit first and then to the final unit you want. In other words, convert the kilograms to grams and then to milligrams. So if you're converting kilograms to milligrams, so for example, if we're converting 70 kilograms to milligrams, we can do this in one step, or you can do it in 2 steps if you feel more comfortable doing it that way. But the first step is to convert kilograms into grams. So just the base unit without a prefix. Kilograms cancels kilograms, and we get grams. Then we multiply by the conversion factor milligrams over grams, and grams cancels grams. So we end up with milligrams. So all we're doing is 2 steps. When we're going from one prefix to another prefix, you have to use 2 steps. You have to convert to the base unit without the prefix first, and then the new prefix second. And then you get your final answer. Or create the equivalent unit conversion. So we have 10 to the 3 milligrams per gram, and there's 10 to the 3 grams per kilogram. So we multiply these 2 conversion factors, grams cancels, and we get a new conversion factor with milligrams over kilograms. And then we simply do one step where we multiply 70 kilograms by the new conversion factor and we get the same answer. So if you feel confident doing that, you can always create a new conversion factor and do it in one step. Pause the video now and try these conversion factors on your own on a separate sheet of paper. And when you're done, unpause the video and check your answers. Okay, here are the answers to the questions. So check your work. If you got any wrong, try to make corrections. If you're still not sure how to do it, ask Mr. Johal for help and try to work through it. Okay, lastly, we're going to talk about derived unit conversions. This is also a review from Physics 11. We're going to change 55 kilometers per hour to meters per second. So the first step is to change 55 kilometers into meters. And we get 5.5 times 10 to the power of 3 meters. The second step is to change hours into seconds by multiplying by 3,600, and we get 3,600 seconds. And then we simply divide meters by seconds to get 15 meters per second. We can do this in one step by chaining the unit conversions. This is called chaining them, where you do them together in one step. So first we convert the numerator 55 kilometers into meters, and then we convert hours, the denominator, into seconds, and all of your units should cancel out appropriately. So kilometers cancels kilometers, and hours cancels hours, and you're left with meters over seconds. So we get 15 meters per second. Chaining unit conversions. An object travels 18.5 kilometers. If the object travels at 4 meters per second, how long will it take? So in Physics 11, you learned equations to do these types of questions in kinematics, but you can also do these types of questions by using unit conversions and canceling units. So the first thing we want to do is change all of the units to SI units. So we change 18.5 kilometers into meters by multiplying by the conversion factor. All of your units have to be consistent first, because this 4 meters per second is in SI units, but 18.5 kilometers has a prefix. It's not SI. So you can't use these units the way they are until they're consistent. That means all of the units have to be in SI first before you can figure this out. And then we can multiply by 1 second per 4 meters, because it's 4 meters per second, but we want meters to cancel. So we cancel the meters and we end up with seconds. 4.6 times 10 to the 3 seconds. We can do this in one step, and we get 4.6 times 10 to the power of 3 seconds. So whenever you're doing questions and you're ever not sure about the units, just convert everything to SI. That's a general rule in physics that we use. When in doubt, convert everything to SI. And that concludes the presentation. You can start working on the practice questions now.